Right, so this is the transonic flow over the RAE 2822 aerofoil. Let me just make this a bit bigger. So, okay, so we're gonna model the flow over this aerofoil, and it's going to be transonic. The Mach number is 0.725, but that's actually going to make the flow supersonic over the wing. So the flow's coming in at 0.725. This is below the speed of sound, and there's going to be a shock wave. Sorry, this is above the speed of sound. There's going to be a shock wave, and then this is going to be below the speed of sound. So this is a transonic wing. The Reynolds number 6.5 times 10 to the 6, and we've got an angle of attack of 2.92 degrees. So the free stream flow is subsonic, and it becomes supersonic over the actual surface of the top surface of the wing. Excuse me. Okay, so that's what we're going to do. Let's start off by importing the mesh and naming the simulation. So we're going to file new, click all defaults. And we're going to import a volume mesh. So that's a C drive. Program files. CD adapter. 12.06. The start ECM. And now we're at the top of the DOC. Start tutorials data. And we want the compressible flow folder, and then data, and then it's aerofoil CCM is the one that we want. That's importing. And there we go. That's the mesh that we've imported. And I'm just going to save that. And save it whatever name you like. Okay, so that's the volume mesh imported. What next step is to convert it into a 2D mesh. So connect mesh, and then convert to 2D. And you need to activate the delete 3D regions after conversion. And then click OK. So yeah, so that's what we get. And you'll notice the geometry parts are in there. And now the next thing is to right click on the physics node, and that should continue it. And right click on that, and we don't want that, so we're going to delete that one. This is stuff that we've imported that we don't need. So we've just got the physics continuous for the 2D. You can expand that if you want to have a look. And then we go on to the next step. Selecting the physics models. So we've already got automatically 2D selected. It wants you to rename that. So the airfoil. There we go. Oh, I spelled it wrong. There we go, airfoil. Okay, and the next step, so continue airfoil. We've got to select models. So if you right click on the airfoil, select models, and then you can select all the ones that you need. So it's saying that we want to select the material as a gas, so we use it air. The flow, we're going to have coupled flow. We're going to use the ideal gas because it's compressible. And it's going to be steady. We're not going to have an unsteady simulation. It's steady. It's going to be turbulent. And we're going to use this Speller and Laveras turbulence model. There we go. And now all the rest of the models are optional. So we've got all the models we need. So we're going to close that. Now inside the continuum node, you can see all of these models that we've selected and some default ones that are selected automatically. And if you want, you can have a look at all those. We're going to carry on. Good idea to save as you go. Now we're going to set up the initial conditions. So initial velocity, 250 meters per squared, and that's calculated as a Mach number times speed of sound, which is gamma RT. So we're going to put these values in. So we're going to specify initial angle of 2.92. So what we're doing here, so let's go on to the tools, the bottom one. I'm going to look at coordinate system, lab, local coordinate system. If you right click, new Cartesian, and that brings up this dialog, and then in the axis definition box, change the I direction to the following. So origin I direction, we want to change that to that 1. So this is the I direction at the moment. That's 1. J direction is 1 in Y. K direction is 1 in Z. And so the I direction, we are changing that to be 1, and then we're changing Y to be 0.051. And what that corresponds to is the angle of 2.92 degrees. And then we, hang on a minute, then we click normalize. There we go. So you've got to type it in, then you've got to click somewhere else, and then this renormalize button highlights. And then what that does, it changes the other values to make it in the correct coordinate system. So it's slightly reduced to X, and then also very slightly reduced to Y. So we've got a slightly different coordinate system than before. And it's done the same in the J. You can see it's automatically done that. Okay, and click create. Okay, I think that's done it. Now Cartesian 1 node is created within the coordinate system, so you can close that. You've got this Cartesian 1. If you click it twice, you might have to delete delete a system. And so yeah, what we can't do is set the axis to a slightly different coordinate system, and that's giving us the angle of the flow. Okay. Yeah, so next thing then, edit the initial conditions. Go back up. Continue initial conditions. And we select the velocity. It wants us to change the velocity to, oh, hang on a minute. Velocity, sorry, the coordinate system, and it wants us to send some laboratory to this new system that we just set up. So this is for the initial conditions, and then the value. Sometimes it's easier to right click and edit. So we just change that there, and then the value we're going to set as 252. There's a little mistake in the solution here. This is like it's in 3 dimensions, 2, 5, 2, 0, and 0. But of course, we've set it up to 2D simulation, so we've just got 2, 5, 2, and 0. So that's a mistake in the tutorial. So that's okay. And the other thing we're going to do is set the temperature. As we click close, click somewhere else just to make sure it's gone in. Keep it on constant. It's gone in okay. Click close. And now we've got to change the temperature. And that's already set at 300K, so we don't need to do anything there. We can leave it. Save. And let's move on to the next step. Setting the material properties. So, yeah, can by all means read through all these changes. What we're doing in the models. Open the air node. You've got material properties for the air. And we've just got to set some of these up. So the first one is dynamic viscosity. If we click on this one, you'll see it's already constant, so that's okay. But we've got to set the value. And we need to change that to 4.58 times e to the minus 5. So it's at 1. That just needs to change to 4. 4.58. Hang on a minute. 4.58. Get rid of those. 4.58 e to, yeah, there we go. That's okay. So that's the dynamic viscosity. Next one is thermal conductivity. So let's just check. It's a constant, so that's okay. And we're going to change the value of that to 0.6. 38. 63814. There we go. 68414. Okay. And that's those two. And again, just check it's gone in okay. Next step, setting the boundary conditions and the values. So there's 2 boundaries. There's the wall boundary representing the airflow itself, and there's free stream boundary at the edge of the solution domain. So before you've had inlets and outlets, and this time we're going to use a free stream boundary. So we're going to go into regions. So this is what we've imported. It wants to change the default fluid node. You can change it to just fluid. boundaries, free stream. So this is all imported. Physics conditions, flow direction specification, and set the method properties of components, which is already used. We can just have a look through the other ones, its components. And then we're going to edit the physics values. And we want to select the flow direction to, the coordinate system. We're changing to the new system that we just put in. Oh. About that. The next one is the Mach number. We've got to change that to 0.7, we've got to change it to 0.725. And return to put it in, and then the next one is the static temperature. We're changing that one, it's already at 300k, so that's okay. So that's the boundary values put in. Let's just save that. Next step, setting the solver parameters and the stopping criteria. So it's just solvers. Coupled implicit. And it wants us to change the current number to 100. Coupled implicit, current number down here. Change that from 5 to 100. Just return to get it in. And then the next thing is a stopping criteria. Maximum steps. It's at 1,000. It wants us to change it to 300. And then that's that done. And then we got to visualize and initialize the solution. So going down, right click on scenes, select a new scene, and it's a scalar. And then we've got this new node, scalar C1. Right click, and it wants us to right click the scalar bar. And we're going to set that as a Mach number. So we've got to scroll down the Mach number, and then use the lab reference frame. So there we go. And now it wants us to initialize the solution. I'm just going to save it. Initialize. And that's setting it as the initial conditions, which was Mach number is 7.25. So you can see the whole screen's gone blue, and down at the bottom you've got 0.725, 0.725. So that's setting the whole of the thing to a Mach number of 0.725. That's our starting position. Okay, and now we want to change the style of the Mach number contours. So we're going to select the scalar scene 1 node, the displayers, scaling 1, and it wants us to set the contour style to smooth field. And then next step, for plotting some graphs, let's save that again. So right click to the reports node, that's up here, right click, and you want new report, and this is slightly different to the tutorial. So new report, you've got to go through the element count. Checking the other one, isn't that yet? So through the element count, and then it's force coefficient. And that features this new new report here. We're going to rename that drag. So right click, rename. It's going to be the drag list. And then we've got to enter the following values. So units, we leave it as empty, that's fine, there's no units for drag. The coordinate system, laboratory, keep that the same. The direction, it's a bit of a pain, we've got to change that according to the coordinate system. So we'll type in point 0, 99. I'm just going to be a bit lazy. 0998, that's close enough. And then for the other component, 0403, that'll do. And then the force option, pressure and shear, reference pressure, you've got to go down a bit, change that. Oh, it stays at 0. Reference density, that needs to go to 1.177. Reference velocity, it doesn't really matter if you put these values in wrong, it just means the actual coefficient won't be correct. The simulation will still run okay. Let's put it in. So, and then the reference area stays at 1. And the actual parts that we're measuring the drag on is you've actually got to select it's the wall. So this is where we're measuring the drag, and this is the airfoil, which is a wall. So that's in there. Number of bands, leave that to 0. Representation volume mesh, and then smooth field, deactivated. So that's all okay. And then what it wants us to do is right click the drag coefficient node, and then create monitor and plots from report. And what that's doing, that's creating this plot, this new plot. It wants us to select that plot and set the title to drag coefficient monitor plot. It's kind of already done that, but you can edit the title and things. But yeah, we'll just leave that. To create a plot for the lift, you do the same thing except you change the axis. So in the so repeat the steps to create a lift plot. All settings are the same, except the direction is in a different direction. So right click, new report, elements, force coefficient, and then you can rename this to lift for this. And then you've got to change the direction to minus 0.4, so minus 0.403, and then the other one is 9981. Okay, hopefully that's okay. Yeah. Just trying to put that in. Oh, field function lift curve. I've got an error there. Unable to. What have I done wrong? Rename the load, set the direction. Minus 0.4. Oh, I've got two. Just get rid of that decimal point there. Okay. Oh, still come up. I've done it again with this one. Okay, so to get rid of that decimal point again. Okay, so let's try that. Okay, so that works. That's gone in okay. So yeah, be careful with those decimal points. Right, select the lift coefficient monitor plot. You can change the title. and then you can also create a monitor and plot from the report form. And so we've got another lift coefficient plot. Okay, moving on. There's some experimental data that you can upload. So right click on the tools, tables, scroll down, right click here, new table, file table, and then we've got to locate the arrow thing. So again, this PC, C drive, program files, second one down, CD Adapco, top one, third one down, and then DOC, and then start tutorials data, and then it's the compressible flow data, and okay, so a slight difference here. So we've got to find error XP. Let's try single, see if it's in there. Not in there, let's go back up, it must be in the other one. Oh, hang on a minute, I've got the wrong files of type. Let's just, so XY. Okay, so it's actually in there, so there we go, error XP.xy. And it found two columns, it's imported it, so that looks okay. Right click on, get back up to the plot. Right click on the plot, select a new plot, a new XY plot. Let's put the new plot in there. And then right click on the data series, add data, and then you've got to select error XP, which we've just uploaded. And then what does it say in the data plot with the error XP? Select data series. We've done that. And set the error XP for the table property. I think you just click OK. There we go. And so we've uploaded that data. That's gone in. Make sure the X and Y columns are shown as below. That all looks okay. You can actually have a look at all the different parts. Right. Yeah. So the next thing, we're going to add numerical data to the same plot. So select X, Y in the parts. So we select X, Y plot. We're selecting in the parts. We want to select the, I think it's a wall. Hang on a minute. So X, Y plot, select the parts, select the wall. This is the one that we want to add to it. Click OK. And now we've got to select in the XY plot the Y type 1, the scalar function. And we want to set the node to the pressure coefficient. We select this field function. And we look down for the pressure coefficient. So many things in here, but yeah, pressure coefficient is the one we want. Click OK, and that's putting the pressure coefficient into the plot. And at the moment it's all 0 because we haven't run the simulation. Okay, the next thing we've got a pressure parameter by specification of a reference pressure and a reference velocity. So we go back into the tools, field functions, and then the pressure coefficient. There we go. and we've got to and enter the reference density. So we've also got to do it for this as well, which is a bit of a, we've done it for the, we've got to do it for this as well, 1.17. Reference velocity. So you can obviously change these, but we're having it as the same as what we set for the initial positions. 252. And everything else I think is the same. So that's okay. Next we go into XY, back to the plot mode. Where are we? XY on plot. The axis, and we are setting the, what's it got here? It's our axis node. Preferred x-axis, so click on axis, is the changing that to the left axis, and then the preferred y-axis we're changing to the y-axis, and set the left axis x, and activate reverse. So I think it's a bit down here. Click the reverse. So that's just shifted it to a more conventional sort of plot. If you unselect that, it's the other way around. So all that's doing is it's switching the data to the more conventional. Okay, we're nearly there. Let's just save that. The next step then, so we've just done all that. Next step is to run the simulation. I've saved it, and now I'm going to run it. Let's see what happens. It's oh, not a lot. Let's have a look at some of these plots. So this is run. Something's gone wrong. Okay, I need to find out what's gone wrong. Let me just stop recording while I do that. Okay, so yeah, it hasn't run for some reason. I've actually no idea why it didn't work. I've just cleared the mesh and it worked. So I'm just going to do that again. Yeah, I haven't actually changed anything, but what I've done is clear the solution, and then I've reinitialized it, and then I've it's done it again, and then I've run it, and it's worked. So I've actually no idea why that didn't work first time. If that happens to you, yeah, go up to solution, clear solution, reinitialize it, and then it works. Okay, so that's going to run away. Let that carry on running. And then you can click through these, the drag coefficient and the lift coefficient. Oh, the lift coefficient hasn't worked. I've set that up wrong. But you can see the pressure plot is working. On the lift coefficient, I must have forgot to select the fluid as a part. I wonder. So if I actually go to the plot, lift coefficient. Actually, it needs to be in this one, I think. I've got all the correct reference densities in there, and I haven't got the part. I haven't checked that one up properly. But if you click on the part, select the wall, click OK. Yeah, it should start to give you a value. But I think that's actually incorrect because I need to set up all these reference velocities and pressures and everything. So that's why that's not worked properly. Anyway, we'll ignore that. We'll carry on. Look at residuals. They look to be going okay. So it stopped at 300. So we've, yeah, because I've not set the lift coefficient, it's not come up properly, but the other ones should be okay. The drag coefficient, yeah, if you zoom in on 0.1, that will give you the drag coefficient. Okay, let's just save that. So there we go, we've run our solution. And then we can actually go on to visualize the results. Yeah, if you zoomed in that section, you would yeah, see what we've got in this, what we've got here. So this is the solution of the whole domain. If you zoomed in on that section, you will see this solution here. Okay, so I'm going to stop recording then.